whether you get a useful result out of this process or not depends very much on what kind of values you pick here. Okay, so you saw before, I picked these and I kind of gave you an explanation as to why, but it wasn't it wasn't a very in-depth explanation. You kind of just trusted that they would be useful. Okay, and it turned out they were. Now, what values should we put in here? For starters, what kinds of values am I going to put in?
Exact values of angles that will give us good values of sine numbers.
Do you remember what I've got here, right? In this middle column, because I'm going to take sine of all of these in the next step, right? From here to here, this column is sine of this column, right? So since I'm taking sine of this column, sine is with angles, right? So I wanted sine of angles in this column. Make sense? So I'm doing the same thing here, right? Being that I've got x, all of these values, I'm about to take the sine of these values, okay? I want to think of some angles in here, okay? So how far did you go back? What kinds of values did you pick?
Minus 5 pi on 6.
Minus 5 pi on 6.
Because I ran out of spaces, I put the 0 in the middle.
Did anyone start further back?
Minus pi.
Now, let me suggest, right, that you should have known to go further back because why do you think I didn't go further back here? Why not have minus 2, minus 3, minus 4, and so on as values to test out? Yeah, it's once you get undefined here, it just gets worse and worse and worse because we're locked in between minus 1 and 1, right? But being that sine, it can take any angles you like. They can be huge, right? The domain of sine is all real values, okay? So how far should we go back? I'm going to go back to 2 pi. Okay, I'm going to go back to 2 pi, right? I think that'll be enough to demonstrate a pattern, okay? What other values ought I to take? What's 2 pi? Maybe 3 pi on 2 pi, minus pi on 2. Now, as we start to get in closer, we can take some smaller angles because we know the exact values for those, right? So, for example, if I go minus pi on 4, 0, pi on 4, pi on 2, pi. So I'm going to get, hopefully, some symmetry here, okay? Right, now, hopefully we know this well enough by now, and I'm not modifying sine in any way, right? So it's just standard old vanilla, unchanged sine, okay? What's sine of minus 2 pi? Can you tell me in your head? It's just 0, right? Okay, minus 3 pi on 2. Where's that? That's, now hold on a second. Okay, so minus 3 pi on 2 is here, right? So sine of that is 1. Yes? Minus pi, that value there, so I'm back to 0, okay? Minus pi on 2, where's that? That's here, right? So minus 1. Minus pi on 4, so I've gone halfway in here. What's that exact value? Minus 1 on root 2. Okay, sine of 0 is still 0. Okay, what happens here? It's an odd function, right? It's an odd function, so I should expect all of these to just get reversed, flipped around. So I'm going to get 1, 0, minus 1, and 0. Is that okay? Yeah. All right. Now, what happens when you take sine inverse of these values? Well, what do you get when you put in sine inverse 0 into your calculator? What do you get? You get 0. Sine inverse of 1. Pi on 2. Now you stop, right? You're like, okay. I've done two values. And I can already see there's some serious changes happening. Okay? So the first 3 graphs I saw told me that it was just equal to x and it just went forever. Okay? But it doesn't take that many values to see, okay, something's breaking quite seriously. Okay? You come back to 0. 0, okay. Sine inverse of minus 1, what's that?
3 pi minus pi on 2.
Get your calculator out. What's sine inverse of minus 1?
Minus 1.
Sine inverse of minus 1.
Minus 1.
It's minus pi on 2, right? It's the angle within the domain of sine inverse. When you take sine of it, it'll give you minus 1. Okay, sine of this does take you back. Okay. Sine inverse of minus 1 on root 2, I'll save you some time. Okay, now this is interesting, right? I started off by saying this doesn't look anything like, you know, sine inverse of sine x. It doesn't look anything like x. But now it's starting to, well, this one doesn't, okay? So this one, not, but now, in here, we are, right? These are equal to each other. This is equal to this, okay? And you can predict, right? Sine inverse of 0 is 0, right? So that's also the same. Okay, now before I go any further, let's actually draw this out, okay? What values am I going to get? Well,
Mr. Williams.
Yes. Sorry, which? Have I gone on?
Yeah, he fixed it. You're getting chopped off.
Wait, can you see that? Can you see the graph? I don't care if you
You
can't see
can
me.
now.
Yeah, okay, great, thanks. Oh, it was just not, yeah, that's okay, it's fine. All right, now, just like here, I'm going to plot my values in, okay? So I'm going to go, what have I got? Minus 2 pi, minus 3 pi on, is this graph going to work? Yeah, it's going to work. Minus pi on 2, and then I halve my interval, so minus pi on 4. Okay, now when I went from here to here, what did I get? I got 0. Okay. Minus 3 pi on 2, the value I got was pi on 2, so I'm going up now, aren't I? Now I'm going to keep this 1 to 1, so it's like a square grid, if you like. So if that's pi on 2 there, okay, here's my value. Yes? What was the next one I had? Minus pi, 0, there. Then minus pi on 2, that was the same value, right? See that? So it's coming down to here. Minus pi on 4, I got the same value. I should really have another color in here, shouldn't I? It's getting a bit confusing. Okay, and we had 0, all right? Now what's this starting to look like?
A sine curve, but not a sine.
Yeah, it's starting to look a bit sus, right? Now you can test out a few more values, but you know, it's linear, right? It's linear. As these change, I could have put in more values in here, right? If I had, say, minus pi on 3, which would be in between here, okay? Minus pi on 3 is going to map to minus pi on 3. Okay, so there are no curves here, right? But if I continue this pattern, it's going to come onto here. Now, I'm guessing it will stop. Why? Why might we guess that it might stop? That is what happened over here, right? But more than that, I can also know that. Yeah, that's true. Well, actually, is it another function? Yeah, okay, it is. What I was thinking about as well is that the domain restriction here, all of these values, right? Because I'm taking sine inverse. What did we say was the range of sine inverse? Remember, go back to your table from yesterday. Exactly. I know I have no y here, but you get the idea, right? So therefore, all the values that this should give us should always be between minus pi on 2 and pi on 2. Okay? So that means I'm locked in here, right? So that would be pi on 2. Okay? And since I'm locked in, what's it going to do? It's going to come back down. You're going to get this kind of shape. Okay? So some of you said it's kind of like a sine curve, but it's not curved. It's jagged and pointy.
Sine
okay?
line.
Yeah. So it's well. How are we gonna describe it? The way we described sine of sine inverse. This is sine inverse of sine. Okay. Well, I can start off in much the same way, can't I? Sine inverse of sine is equal to x in a certain domain. What's the domain?
Minus pi on 2 is less than
Yeah, good.
x, isn't it?
Just in that little spot there. Okay. For. Okay. Now, how do you describe the rest of it? How do you describe the rest of it? Is right. Now, you can use like you can say jag or whatever. I'm gonna let you think about it for a minute. Okay. At the end of the day, probably, I'm gonna ask you, what did you come up with? I think there's got to be at least 2 or 3 different ways to describe it. Just like here we said, well, it doesn't exist, so it's undefined. Okay, no problems, right? Well, how are you going to describe this? What's that equal to? And what about this one, right? How are you going to word it? How can we geometrically describe it? Okay.
Use like general solution.
Kinda. All right, now, I walked you through this, okay? And then I sort of let you flounder around and walked you through that. I want you to do the same for, can you guess? Okay, so let's do cos and cos inverse, cos of cos inverse. Then let's do cos inverse of cos. Now, by the way, before you actually start testing any values, right? I think having gone through this process, you ought to be able to make some educated guesses before you actually start doing this to save you a bit of work, okay? So what I want you to do before you start calculating values, okay? Just make a hypothesis, okay? Think, I reckon it's gonna look something like this. You know, write something like this. And if it's totally wrong, that's fine, okay? I just wanna see if you can practice your mental chops rather than just go through it mindlessly and, I don't know, it looks like this because it does, okay? And then if you're surprised, then that'll be something that we can pursue, okay? And again for this, you know, we've seen that something different happens when you swap the sign and sign inverse. So we would expect the cos and cos inverse to do the same. And I'm probably just going to give you tan and tan inverse because by that time you'll be sick of it, okay? So you're probably going to do that until the end of the lesson, but in period 7, I'll show you the answers, okay? But I want you to have a go. Yeah, it keeps going. It keeps going. And the reason it keeps going, it's kind of misleading to have arrows, isn't it? Because arrows kind of it suggests it just goes and goes and goes. But it has this same kind of, it's periodic, okay? And the reason why, think about it this way, right? Why is this undefined for certain values, okay? And the answer is, because this is undefined for certain values. This is the crucial part. It's the middle part that's important, okay? Now just like this is undefined for certain values because this graph is periodic, just like this is. You see that? It's the middle part that's definitive, okay? So yes, it keeps going forever. It keeps on bouncing up and down just like sine does.